Hi, everyone. Thank you very much for taking the time to listen to us today. Again, I'm Daniel Calabro, this is Thad Teo, and we are the Ferris team. And we felt like this is a really good time to sit down, introduce ourselves to you, and tell you what we're building, what our dreams are, what our aspirations are, and kind of how we see this thing playing out and how we want to build this uh, operating system here into the future. So uh, I think it was a good time because when we started this project back in March of 2025, Thad and I, we knew each other, but we knew each other through a friend, and we were working remote for the past about 5 months now. And this is the first time that him and I got to meet in person, and we're having like a hackathon week, sitting down together, getting ready for a really big fall, a lot of products to push, a lot of clients and customers to serve here at Ferris. So we're really excited about it. And Thad, for you, how was it working with me, someone that you never really met in person before, remote? What we're building here is really intense, and at times I ask a lot. So I kind of want to get your vibe on what that was.
Yeah, I mean, first off, it's kind of crazy that you're not just some laggy Google Meet avatar. So that's really exciting. But I will say, obviously, the energy that I feel from you, like just through our calls, even though I haven't met you, I feel like I've known you like a million years. Because whenever you're talking about Ferris, like it's like your passion, and that's like who you are as a person. I feel like it's something that's kind of embedded in you. And so when we talk about Ferris, I feel like we're kind of talking about an extension of yourself. And I'm really excited to be a part of that energy and be a part of what we're building. And, obviously meeting each other in person is also really crazy. Um, you're a lot taller than I thought you were, so that's kind of awesome. But yeah, I mean, the fact that you're able to hop on a flight and just immediately come through to the DC area and have that same energy that you have when you're building in your own private space and like you're in your own comfort zone, like the fact that you're able to maintain that level of energy is insane. So
Thank you, man.
kudos to you. But yeah, I'm really really excited that we're able to do this in person and have this week to ourselves to really build and ship something super awesome.
Thank you, man. I appreciate that. And yeah, that energy comes from a place, I guess, of I wanted these tools for myself as a civil engineer. I was looking
Mhm.
around and I saw how we were working and the workflows that we were working in, and they just were not optimal. And for me, I was always trying to say, hey, like, what can we build? What can we make better? And this is something that I really believe is going to make the experience of being a civil engineer much better for younger civil engineers and hopefully more experienced engineers that really take this technology to the next level. And we've been seeing that right now with the customers that we're servicing and the products that we've been developing. So I'm really excited about that. And that same thing for you, man. Like working remote, we've been working weekends, we've been working nights. It's really intense. And I know Ferris isn't the only project right now on your plate. Like you do have a 9 to 5 because we're not a VC backed startup. We are bootstrapping this and we have to pay rent. so we make time for Ferris where we have time to. And hopefully that's gonna change here in the future. We can go full time here on Ferris and really dedicate all of our time and our energy to this project. But yeah, man, I really appreciate your dedication. Your expertise in software development, AI, ML has been invaluable to this team, invaluable to this project. I'm good enough with coding to be dangerous, but but past that, I mean, I definitely need help. I'm not the best developer out there by any means. I'm not the expert in any of these things outside of civil structural engineering. I think I'm pretty well versed in that, and I think that's where we make a really good team. To be honest with you, it's you bring that AI, ML knowledge base and experience. I bring that civil structural engineering experience, and we kind of build the bridge between those two worlds because that's kind of where I see the disconnect in, I guess, AI space, bubble space, and then the reality, like all these verticals that people are trying to build. There's a lack of connectivity between the SMEs on both sides, and I feel
Mhm.
like Ferris right now is a representation of these two SMEs in these two fields coming together and building an awesome product that's going to serve a very specific vertical that needs a very specific tool and platform to service them properly. So I'm really excited about it, and I know a lot of our customers are really excited about it too. Some of the agents that we've been able to develop so far are Deep Query, which is just document analysis. And what was one of the hardest parts about designing Deep Query for you? Because we talk about this context window and how hard it is to increase it. It comes at the price of this extra compute that you have to run. For you, from a technological perspective, like what's really difficult about that?
Yeah, I would say relevance is the number one thing. When we're talking, I'm going to go in a little bit of a technical rabbit hole here, but when we're talking about querying some sort of document semantically, obviously there's a lot more power to just being able to say, hey, where can I find this instead of control Fing and trying to get the right keywords. As you know, with a lot of our documents, sometimes they're like scanned and they don't get picked up by something like the text parsing. And so for us, it's relevance. I mean, we have thousands and thousands of page, a significant amount of gigabytes worth of data just in like a project space. And so trying to identify, hey, like, is this particular piece relevant to the question that we're asking? And, should we serve that to the user as a potential answer? Now, the way that we do it, it's quite a complex thing. And, with Ferris, we're, taking a lot of pride in the fact that we have pretty strong accuracy and we are able to deliver the results that we need to for the customer. And the way that we do that is through sort of a two-step ranking system, which took forever to try to build. I mean, GPT at this point probably hates me. Our AI, our LLM systems probably hate me at this point because I'm just constantly saying, hey, this is not right. Please try to do this again, and just trying to figure out the exact way that we can really get the value out of our queries. And, that's sort of more of an art than a science. I see a lot of papers on, performance and benchmarks for different LLMs, different models, and things like that. And when it comes down to it, they'll release those benchmarks, and everyone, at least every engineer and even every layman that uses it, they're like, it's not really that much better. And it's really more about how are you utilizing that tool? How are you, constructing your prompts? How are you, bettering your, I'd say, your questions in order to get the result that you want. Now, that's part of our customer experience as well, is the idea of education, or like prompt engineering is kind of like the huge keyword here. Um, that's not something that's very familiar to the majority of people that are, in the civil engineering space or the AEC space. And I feel like with Ferris, we're trying to bridge that gap between utilizing LLMs properly and utilizing AI with prompts and trying to get the exact output that you need. We are soon, very soon, releasing a Ferris University, which will be heavily catering towards the engineers that are actually going to be using this platform day to day, to give a crash course on how do we actually interact with not just Ferris, but AI in general and LLMs. We know that AI is going to be taking over a significant amount of what we see as work today, but I think that the root of it all is going to be that humans are still going to be the ones that are using that driving effort to use AI as sort of its assistant rather than taking over the majority of the work. And with that, we need to be able to be prepared to use AI using the proper jargon, the terminology, and just having strong prompt engineering output, really.
For sure. And we always talk about prompting being like that first edge of the sword. Really important to get your prompts in there in a very organized, specific, calculated manner to instruct your large language model to operate in the fashion you're looking for it to operate in. But then also, which I think is unique to the civil engineering field or engineering in general, but a lot of these fields, that the output is so important. And when you're polishing an email or maybe like crafting up a poem, the verification on that is a very low bar. It's like you can kind of get away with mistakes here and there. But when you're dealing about civil engineering and you need to have variables and pieces of information accurate to the decimal point, and you have people signing and stealing and putting their name on the output of this AI legally, it brings into a whole other question of how we verifying and vetting this information. I know that's something that we work on every day. It's at the conversation topic that we're always trying to have and to try to find the best ways to make verification proper. Right now, we provide links. We're looking into other types of mechanisms to increase the level of confidence that you have that, hey, at Ferris, when it knows something, it tells you what it knows. And when it doesn't know something, it also tells you what it doesn't know. And from that, we could deduce, okay, this is what we have. This is what's true, and then this is where the engineer, the human, needs to step in and provide their expertise and their experience in order to go ahead and provide value to this workflow that we're developing here at Ferris. So verification, prompting, double-edged sword that we deal with on a daily basis, and it's been interesting. It's definitely evolved. At first I thought it was always just gonna be the prompting aspect of it, and then you start talking to engineers in the field, and I start playing around with the software as well when we were in like MVP land before we even launched officially, and you're like, well, this looks really good, but how do I know if it's right or not? Because if it's not, then it's invaluable. There's no value there to me. So again, trying to figure out ways to use generative AI to provide value. And I think we've done that really well with our recent agent, TempGen. So what we've been able to do here is turn your hand calculations or your PDFs, like design guides, and with the click of a button, Ferris is going to go ahead and turn those into functioned Excel spreadsheets for our users. And this was something that a lot of our engineers were asking for as we've gone commercial here with Ferris, and I talk to engineers all over the world. Many times I'm in meetings and these engineers will go under their desk and they'll pull up a binder, they'll like wipe the dust off of it, and they'll say, hey, I got this giant binder of hand calculations that kind of just sits here. Can we do something with these? Like, is there a way that Ferris can understand this? And that and I went back to the drawing board and we were like, what if we just took those hand calcs and with the press of a button converted them to spreadsheets? Now, that hand calc that's sitting under the desk can now get shared with your team. It's now turned into a template, which is easier to submit, easier to use. And that value is now unlocked. That's just been sitting under there. Maybe someone might have thrown it away at some point throughout their life cycle at the project or the company. So we're really happy about that. That was really hard to build, dude. Like, I was trying to build it before you and I were working together, and the problem that I was always having was the functionality within Excel. So I could get the large language models to understand what was getting ingested, but that output was very difficult to structure. How did you go about doing that? Like, what was your framework when you were trying to tackle that problem?
Yeah, so if you remember, very late nights. Then part of those late nights was really just me like hitting you up with a bunch of questions like, hey, what are we typically seeing inside of these calculations? And I think that there was one thing that you texted back to me that really struck out, and it was everything past calculus 1 we don't really do. And that was like, oh my god, okay, let's go back to calculus 1. And like, after thinking about that a little bit more, I mean, Excel is a massive like behemoth of things that you could possibly do in it. Obviously, for the majority of people, we're just using it for like really simple sums and all that arithmetic. But there's a lot more that you can do inside of a formula, inside of a cell, for an Excel spreadsheet. But when we really just scoped it down to what are civil engineers typically using inside of their calculations, mostly just arithmetic, if not just a little bit more advanced mathematics, but really nothing out of the ordinary. And so when I scope it down and I have a bunch of different calculations that I can kind of work with, it really ended up being quite simple from the Excel side. Part of what Dan said was, let's think about the context window, and we want to make sure that all the data we have is relevant so that that context window isn't muddied with noise. And it's sort of the same principle here, where there's a whole world of different Excel things that we could do. Let's just limit it to these like 10 different things that you could possibly, like you could do multiplication, subtraction, addition, or like some sort of variable swapping. And when you scope that down, it makes the world a lot easier in terms of translating some sort of structured output into an Excel spreadsheet. Now, the idea of going from an image to that structured output is a whole different game. Again, that's part of the secret sauce that we have here at Ferris, and being able to parse any sort of document, PDF, image, whatever, and being able to get that structured output, and then turning that structured output into whatever we want. I like to think of Ferris, this is something that I've always just kind of internalized as that like little adapter in a series of cables. I don't even know if that's the right terminology, but being sort of that key piece in order to connect two different systems, whether that's a document type to another document type, or a software vendor to another software vendor that's in the works. Being able to sort of translate that unstructured, like here's just a random document, can we then convert it into something that's more meaningful? I feel that's part of our secret sauce, and something that, again, we're very proud of.
Definitely. And when you were saying before, when I text you saying, hey, we're not looking at anything over Calc 1, I think the nature of like understanding your problem is really important, because as a civil structural engineer, what you're going to be doing from a hand calc perspective or something that's like a PDF form, typically nothing that's going to be like a finite element analysis or some sort of computational fluid dynamics where there's integrals and derivatives involved. It's really going to be that base level mathematic problem that you're trying to solve there, because anything that gets more complex than that, it's no longer efficient to solve by hand, and you typically put it into a structural analysis model or something of that effect. So I think having that moment where I was like, let's try to just get to the core, the simplest problem, like where we're just calculating like moments and shears and deflections and these mathematical problems that you could solve by hands, and then translating that over to an Excel sheet. Very powerful. Our users were asking for it. They've gotten the beta so far. I know we've got room to improve on all of our tools, but especially TempGen. So we're going to keep working through that. And I'm really excited to keep offering products like that the community is asking for. As you go around and you start looking through the workflows of civil structural engineers, there are just so many areas where we have these processes, these procedures, these workflows, and they're just massive amounts of decisions that get made throughout these workflows. And something that I'm really excited about with AI is the ability for AI to scale an engineer's judgment and experience and knowledge. So when we talk about large language models, reasoning is always something that gets brought to the forefront. How well do they reason? Do they reason like a human? And in my experience, you can correct me if I'm wrong here, but when you're outside of that trained data pattern, that reasoning kind of falls off a cliff. And when you're in these gray zones where you haven't had these problems before, the large language model does not know what to do, and the performance it falls off and dies. So what I think is very valuable is whenever we're within this known area, places where engineers have studied, they've worked many years of experience, and they kind of know what to be doing in these areas. Like, for example, when it comes to a concrete submittal design report, we know all the logic checks that need to happen. And what you could do is you could train a large language model on that logic that you built up for water to cement ratio, aggregate size, admixtures that are needed, compressive strength, and you could really put together a standard operating procedure within Ferris. So that way, when you're doing this concrete submittal report, you bring in the design report, you bring in your project data, you have that submittal recipe that we call it, that logic and experience that you've cultivated, and now the large language model can scale that that prompt, that piece over 100 different types of submittal reviews at the press of a button very quickly. And that's what I'm really excited about. I think when people talk about AI, they're always like, oh my God, it's going to steal all of our jobs and take away everything that we're doing. And I'm curious what your perspective is on that, because I feel like large language models are much more advanced in the computer science space. Like we're building one right now for the civil engineering space. But do you see it being something that like you're worried about your job placement in the future?
Yeah, well, honestly, I think that you kind of answered this question yourself, where when we're talking about AI and reasoning specifically, it tends to fall off when it's not trivial. And just as a little bit of background, I come from a software space, traditionally software engineer, and that's the majority of where my work experience lies. So when I work with my peers and I see the things that they're working on, they're using AI for things like, unit tests, which is essentially like, hey, I have this sort of code and I just want to make sure that over time, if anything changes, like it doesn't break. So
Yeah.
we just run these tests continuously. And oftentimes it's also like really standard. We call it boilerplate, which is code that you kind of just have to write in order to get the output that you want, but it's a very, very solved problem.
Mm-hmm.
Now, when you start getting into more deep technology or deep research or any sort of work that really requires you to turn on your brain and lock in, AI just is not the best buddy for you there. It can help you think through things, but it cannot really give you output, because what we've seen, especially with Ferris while building Ferris, is when AI is wrong, it is very confidently wrong.
Mm-hmm.
And so part of why I don't think I'm very fearful of the software engineers, my peers, being laid off and like all this craze so that we could just hire a bunch of AI workers. I still think that there's a lot of deep work that a human needs to be able to do
Mm-hmm.
in their day-to-day job. Now, granted, a lot of the work that we do is going to be monotonous and is going to be something that traditionally would be very slow if we were doing it by hand.
Mm-hmm.
And one of the things that I've seen, now this is really just based off my own experience, but the majority of times when you see an error happen, it's not because it's some crazy hard calculation or some really deep research where you're hyper focused and because there's so many moving parts, like you just missed something. That's typically not where you see errors. You
Mm-hmm.
typically see errors when you're working on things that you just in your brain note it as, oh, that's very trivial. And you don't give it as much focus. You don't give it as much thought. And so
Mm-hmm.
you're going through the motions and oh, there you go, an error. And obviously in software engineering, it isn't that big of a deal. I mean, another engineer can probably find it and like, do whatever, or maybe Instagram will be down for a day, like whatever. But obviously in civil engineering, we understand that the stakes are much higher. And when we interface with an AI, having the ability to at least be confident that someone else, even if it is just an artificial intelligence,
Mm-hmm.
was able to check your work, and knowing that you probably weren't 100% that day when you did that hand calculation or did whatever,
Mm-hmm.
and having it just be thorough and checking it as if a human would, that's really valuable. So I still think that there is going to always be a place in AI for assistance, but humans are needed for that deep work. And I don't think that we're going to be going anywhere anytime soon.
Definitely, definitely. I feel the same way in civil engineering. I always say for young kids that are like in high school, like they're trying to figure out what they should be doing. And I think being in any engineering field is always going to be in high demand. I think solving problems is very nuanced. And as we were saying, kind of the theme of this is like, if you don't have data to encapsulate the problem, it's hard for a language model to solve that problem. So as we grow as a society and as our technology gets better, and we might be creating more data and training large language models on more data, but are we always going to be at the edge cases of every problem that we solve? And that's something that I'm really worried about our generation. I hope we don't fall into this trap, is we have like this very unique problem solving muscle in our brains that I think you need to flex and you need to work on in order to have it. And I really hope that we just don't like rely on AI and make that muscle like really soft and really mushy. I hope, and I see a lot of our peers that are just out there working on really, really cool, really tough problems. So I'm very optimistic about that, but I just don't want us to sit around and like rely on this technology as a crutch.
Mm-hmm.
So to your point, like what we're building here at Ferris is not just like this plug in and click and you get this blind response and you just copy and paste it onto like your RFI response and you send it out and you say everything's good. It's not what we're building here. We're trying to build a tool that, yes, it will scale your engineering judgment, your knowledge. It will get you information faster. It will curate that so you can make a design decision faster. But it's also an education tool that we've realized. And with these standard operating procedures that we've created now, when you've got young engineers and they're looking at these submittal reviews for the first time, the senior engineers and the senior management have sat down, they've crafted these recipes, these prompts, and within each logic check, there's an explanation as to why that logic check occurs. And why this is really important is obviously there's a shortage of civil engineers in the country, and a young engineer, they're doing a lot of different things. I called it a baptism by fire when I was a younger engineer. Like I was in the field doing inspections all day, doing submittal reviews, doing new designs, doing rehab projects, like all in a 12 to 14-hour day. And you have so many questions when you're out of school because they can't teach you all of that. And what you would do is you'd go to your senior engineers and you'd try to ask them, but they just didn't have the time. So now, what if you were able to offload some of that EDU space to a Ferris, like a platform like that, where all these submittal reviews or any sort of standard operating procedures that you might have at your company, you can now put within Ferris. And whenever your engineers have questions, they go to Ferris and it has the answers for them. So that's something that engineering teams that we've worked with so far really like, and I'm very excited about it. I'm really curious from your perspective as a software engineer, what is something about civil engineering that's kind of like surprising to you or like that you didn't expect? And as you're learning more about the space, like what do you think is pretty cool about it or interesting?
Yeah, I will say the fact that there isn't just a metaphorical, but a real physical binder that you guys whip out and reference is insane. Like, I don't think I'm not going to say that it doesn't exist because I'm sure that there are some software companies out there that do this, but I don't think there exists really any sort of physical item that we'll ever have to reference as software engineers ever. Partly because just the nature of our work is very much on a computer, everything's digitized. And the other part is just, my God, that takes forever. And yeah, when you told me that, like, no, there is literally a binder. And I was like, okay, yeah, I get it. But like, sure, it's a large file system. Like, where do they drag and drop? And then he's like, no, like, let me go show you real quick. So I remember like we had a call. He was in his bedroom. He like went to his bookshelf or whatever, and he just whipped out this massive binder. And I was like, okay, that's what we're working with.
Yeah, I
And
mean,
that was like my onboarding phase of just like, okay, I am now turning on my civil engineer brain, and like I gotta really think like a civil engineer. And honestly, I think that that's kind of what the past 5 months has
mhm.
just been like me looking at exactly like what you're doing and like how you're doing it, and just absorbing as much as possible. And it's so astonishing. Now, one of the questions that I had for you, so I've been working, just on the side with small businesses and like mid-market companies working in operations. So
Mhm.
this is standard biz ops. And part of the work that I'm doing is, okay, let's try to take a look at, your standard operating like procedures and automate it. A lot of the stuff that some people do are like, all right, I live in spreadsheets all day long and I copy and paste from this thing to that.
Mhm.
And it's kind of easy to automate that sort of thing. But from a civil engineering standpoint, I want to hear your thoughts on sort of like the long-term goal of like what Ferris is going to be from an operations perspective. Because when we're looking at a traditional civil engineering firm, I mean, obviously Ferris doesn't even exist in that landscape yet
Hmm.
for the majority of engineers. And so I want to hear, how do you want to interact with, or how do engineers today want to interact with Ferris? How do you think that Ferris is going to grow with them in the long term? Instead of just being, this platform where you could get really strong output really, really fast, like
Hmm.
where do you think that it's going to blossom into inside of your operation stack?
So what I like to do is sit down and kind of think about what is the civil engineering workflow going to look like in the year 2030. So
Hmm.
we're here, it's August 2025 right now. You go turn on LinkedIn or X or whatever social media feed you want, and everyone's coming up with like a new AI agent or a new AI bot. And they're powerful, but I think in an isolated environment, it's not going to solve the true problems that we have as civil engineers. And I think one of the main problems that we have is we deal with just this massive amount of data. Like before, you're like laughing at like, oh my gosh, you guys have actual like binders and books, and you have the American Society of Civil Engineering code, and you have all these highlights and tabs in it. And it's not, we don't do that because we don't know how to use computers. We do it because it's the easiest way to get to the information. Like we
Yeah.
find the path of least resistance. And when you're in a PDF and you have to control F and hopefully there's metadata behind it, and then you have to just like look for hot keywords, that sometimes takes more time than if you knew the code and you kind of had some tabs and you knew, oh, okay, there's ponding. Looking at the AISC, I should probably go to like chapter J, it might be like Apex Appendix 2 or something like that. And you kind of flip through your tabs, you open up your notes and stuff like that, and then you just get to that spot. So where do I see this going and what do I see this workflow looking like is I see Ferris, like our logo is this Ferris wheel, and you have all these carts around the exterior, and then you've got that central hub in the center. And I think that central hub is where we will live in the future of the civil engineering workflow. You were saying it before, you kind of see Ferris right now as like a converter, like you take one data source and we turn it into another data source. I think you take that and you can extrapolate that here into the future and say, let's take an operating system like a structural analysis model or your drafting model or your internal server, and instead of having the human always being the one to transfer and translate that data to and from softwares, you can go ahead now and Ferris will be prompted to do that for you. So let's say you're in a meeting and you want to know all the answers in your meeting. So Ferris is really nice for that right now. If the architect asks you a question about your drawings, you don't have to really flip through it. You just ask Ferris what it's asked you, and then you give the accurate response. But let's take that like 2 or 3 steps forward. And let's say the architect wants to take your column and rotate it 90 degrees and change the profile. Currently, what does the engineer do? They note that down, they go back to their analysis software, they make that change, they see what the results look like and say, hey, yes or no, we could do that. Well, what if Ferris could take that request, go run it in your model, bring those results back to you and say, hey, Dan, structural engineer, this is what we're looking at now in your model. This is what your structural system looks like. Are you comfortable with these changes? What do you want to change from here? And taking that data work, that workflow that we were talking about, taking it from like point of problem to point of solution very quickly via Ferris is where I see the future for us and where I think we should be building into 2030. So I'm really excited about it, and that's a really good question. Thanks for letting me highlight that a little bit more. I think that's for all for us today. I really appreciate it. Check us out at askferris.io. And if you want to reach us on LinkedIn, you can find us both there as well. We're going to be posting more content and building a bunch here. So thanks, man. I appreciate it, and I look forward for the future.
Absolutely.